right, we'll go ahead and start up the webinar. Hey everyone, welcome. Thank you so much for joining us today. We're going to give a couple of moments for everyone to join on. My name is Karen. I'm part of the Stream Native team. Welcome everyone. We're going to be getting started in just a couple of minutes. While you're waiting, down at the bottom, if you wanted to include in your chat a little bit more about where you're calling from, or a little bit more about where you're calling from out here in the world. And then also, if you happen to be, let's throw a random question in. How about that, David? If you are team cat or team dog or team something else, I'd love to hear a little bit about that too. So. Welcome, welcome everyone. I see some more folks joining in also. Thank you so much for joining us today. We're going to be getting started in just a couple of moments. All right. Perfect. Hi everyone, my name's Karen. I'm part of the Stream Native team. We're just giving everyone a little bit of time to log in. I see some more folks jumping on. David, shall we do a mic check with you? How are you doing today?
I'm doing fantastic, Karen. How are you?
I'm well. Now, I know I can answer for you where you're at, as well as I think I know the answer to whether you're team cat or team dog.
You do, huh? Okay, let's see. You're right.
No, I might get this wrong. I know Tim, and I know Tim's out there too. So.
He already posted. He's Team Cat. He's
Yes, team
cat.
cat. Actually, David, I don't think I know.
I own neither. I have no pets. So.
Oh yes, thank you, Tim. Tim.
Team Pulsar. That's right.
Team Pulsar. That's awesome. Team Mountain Lion. Thanks, everybody. I see a couple more folks jumping in too. We're going to be getting started in just a moment. Perfect. So welcome. While we're waiting for everyone to filter in, we've actually got a couple of poll questions that we're going to be spinning up. So let me go ahead and bring those up real quick. So part of this is just learning a little bit more about everyone's background and where folks are coming from. So the first question that we're going to launch is, what's your familiarity with event sourcing? And you'll see here in just a couple of moments down at the bottom the poll question itself. A couple of the answers to that, I've heard about it, but that's about it. I'm brand new to it or just getting started. I've dabbled here and there with event sourcing. I'd like to get started with event sourcing in the next 3 to 6 months, or I'm an expert when it comes to event sourcing. And I see a couple of answers coming in. We'll give it a couple more moments as people put some answers in here. And welcome to everyone else that's joining in also. We're just running a couple of poll questions while we wait for more people to join in. All right, I'll give it another about 10 seconds for this one. All right, let me share the results on here. So it looks like we've actually got a pretty good spread across all of this. A couple folks that have heard about it but are new to it. Looks like we've got an expert in the house also. So a little bit of information across here, but yeah, good spread. Nice, Tim. And I see some more people that are joining in also. Welcome, everyone. We're running a couple of poll questions while we wait for all of the attendees to drop in. So let's go ahead and get started with the second poll question. Okay, next one. What technology are you using for event sourcing? Are you using Pulsar, Kafka, or none? Or other event sourcing database? And if it is a different one, we'd love to hear what that is if you wouldn't mind putting that in chat as well. A couple of results coming in. We'll give it a little bit of time for everyone to have a chance to answer. All right, let's give it 10 more seconds. Okay, so let me share out the results on here as well. Again, looks like a pretty even spread. For those of you that answered other, we'd love to know what you're using with that as well. Thank you. Thanks, Alexander.
That's yeah.
Yeah, so it looks like Pulsar. Yep, that could make sense. Excellent. Oh, Patrick, thank you. Yep. All right. And one more question while we wait for a couple more attendees to join in as well. Final one, are you using event sourcing? Yes or no, but I'm interested in learning more. Let me go ahead and launch that one up. Great. Ooh, I'm seeing it wiggle back and forth a little bit between. Give everybody a couple more moments to fill that out. Perfect. All right. So this one a little bit more definitive. Let me end this and go ahead and share the results out. So it looks like a lot of us are here interested to learn more, and a couple of folks who are currently using event sourcing. So that's it for my poll questions. It looks like we're holding pretty steady on our attendees also. So I'll go ahead and stop sharing on here. And let's go ahead and do a little bit of an introduction and get everybody started. So welcome everyone, and thank you so much everyone for joining us today for the webinar, How to Build an Event Sourcing App with Apache Pulsar, hosted by Stream Native. We're so excited to have you all here joining us today virtually. So I'd like to go through just a couple of housekeeping items before we get formally started. Please feel free to use the Q&A function at the bottom of your screen. Submit any questions at any time that you might have throughout the event. We'll do our best to try to answer them as they come in. However, we also have time at the end for Q&A as well. Please feel free to also use the chat function for any comments that you might have and want to share with the group. This event is being recorded, and it is going to be made available to everyone by next week. So with that said, I'd love to go ahead and turn it over to your speaker for today, David Karengard. So David, please go ahead.
Right. Thank you. Thanks for that introduction, Karen. So yeah, today's webinar will be on how to build an event sourcing application using Apache Pulsar. And as Karen mentioned, my name is David Karengard. I'm a developer advocate at Stream Native. A little more about my background. I'm also a Apache Pulsar committer. I'm a committer on the project. I've been working on the project for over 4 years. And during that time, I learned enough knowledge to try and share that through a book called Pulsar in Action, which is available for free download on the Stream Native website. I encourage you, if you haven't already got yourself a copy of that, to go sign up. You just put in your enter some form information. You get a free PDF version download of the entire book, which is a really nice benefit. I encourage you to go get that resource. Prior to coming onto Stream Native, I was a principal software engineer on Splunk's messaging team, responsible for Pulsar as a service platform for large scale customers, handling petabytes worth of data volume per day. So I've operated very large scale, very small scale, a lot of different customer environments. I'm very familiar with the ins and outs of Pulsar. Formerly director of solutions architecture at Streamlio. Just mentioning that because that meant that I've engaged with other customers and they have solutioning around. So we decided on Apache Pulsar. We want to use it to solve this particular business problem, help us figure out best practices and ways to sort of put it in line with those sorts of, to meet our use case, and event sourcing being just one of those many use cases that people wanted to do. And then just some stickers here where I've worked in the past in my illustrious career. A lot of diverse background from defense contractors and logistics companies to insurance and a lot of big data companies, Splunk and Portworx among them. So let's talk about a little bit about today's agenda, outline of what we're going to cover for today. We'll start by comparing and contrasting state-based and event-based data models and how they take different approaches to recording the state of a software system. Then we will define what event sourcing is at a very high level and how the CQRS, or the Command Query Responsibility Pattern, is used in conjunction with event sourcing to provide good read and write performance. And then next we will discuss the 3 different event sourcing use cases. I'm going to demonstrate, starting with a review of the application architecture and drilling down into the individual use cases. Have code samples available in a GitHub repo where you can go grab this after the fact, and you can play with it yourself. But that's an outline of what we're going to be doing for today. So again, for those of you who are experts in this is probably gonna be review. People brand new, this is sort of a introduction, so bear with me on this a little bit. We'll talk about state-based versus event-based data models. So as you can see, state-based models are your more traditional way of recording data. They record a position or state at any point in time using a database and then a synchronous call. So think of it, for example, if you're recording a checkbook balance, you create a transaction, do a debit from your ATM card, you start a database transaction, you subtract the funds from your account, transfer it to customer number, the other customer to the vendor, complete that transaction, update that balance, and you have a new active balance there. But you only have one field where you're actually recording that, right? And that supports, as you can imagine, the full CRUD semantics: create, read, update, and delete semantics on a database. You do all four operations. And you're doing reads and writes on that same data source. So that's your traditional way of storing data, and it's a state. It represents the current state of the system at the current point in time. Now contrast that with event-based data models in which you record all the events as an immutable sequence in which they occurred. So, I did transaction A, I moved funds from, I did a deposit, I did a debit, you enter that in the time that it occurred, and then you can record all these different transactions. And this allows you to, it represents a transition from one state to another, right? So I went from the state where I had $500 in my checking account, I did a debit charge of $50 to a vendor, and then I could, but we don't update the state there and say, now I have 450. We just say, I just did a debit of $50 and I record that when it occurred. Now the current state, you can calculate the current state from that, obviously by, going back in time and replaying all those events up to this given point in time, or if you want the current state up to the current point in time to calculate that same checkbook balance, right? So you go back to when I first did initial deposit, and then, I opened the account, put in $50, and every deposit and subtract, check and debit card. Since then, you can just replay all those, do a plus or minus, and you come up with the exact same, hopefully the exact same value that you do if you did it in a state-based model. But as you can see, there's a larger volume of data, and you record all that information. So graphically, we can sort of look at it like this, right? State. So let's look at, for the use case we're going to talk about today is a food delivery application based on my book. Again, as I mentioned, I do this fictional food delivery company called Gotta Eats, which is very similar to like an Uber Eats or Postmates or something like that. And you have, a network of drivers delivering a food to a network of customers, right? And they're going to sign in and sort of see their information. Now for the state-based model, right, you're going to record the driver's location at any point in time, right? So we want to, record this information and use a single shared database to record each driver's current location using standard CRUD semantics, right? So we perform destructive operations such as database updates and deletes. And as you can see here, for every individual driver, there's exactly one record. And that record indicates the most recent value we have from that driver's tracking device, where they are on the street, what their latitude and longitude is, and the timestamp of when we last got that information. And that's a single state-based model. And then the drivers who want to go back and when they open up their application and need to find drivers within their area, for example, then they're going to go query that same database to get that information and then drive their app. So again, it's one database shared across reads and writes. Now contrast that with an event-based model. It's quite different when applied to the same problem. To reach the current state of the map, rather than taking a snapshot, we would just replay each driver's move from the start to the present, one at a time. So you can recreate the map at any point in time using this method. Each driver's move is an event, or a transition from one state to the next. And the event doesn't need to contain information about the other drivers on the board or where they are on the map. But unlike a state-based approach, you need the entire stream of events to derive the current position or the track the route that the driver took. So as you can see here, as indicated by the color, there's multiple entries per driver in this particular case. With the newest one, over time, there's going to have different timestamps, right? So the orange one came in and he moved, across these different events. He published an event and then a new position update and a new one. And so if you wanted to find their current location, in this particular case, you would just take the top most recent value of each of these individual drivers, right? So the purple driver we know is at latitude 6531 and that longitude of -114.8. And similar for the orange. But if we wanted to replay all these events, we can go back and figure out which route they took, how long they got stuck, and what their actual transit time and things like that. So there's an additional data kept there and we store it completely different using an event-based data model, which is the basis for event sourcing, which we'll get to here in a second. So to sort of summarize some of the pros and cons of the differences between these two, we'll sort of talk about this chart a little bit here. So again, with a state-based model, you have full data consistency. You're using full asset semantics. You're probably using transactions on database. And so the data you write in there is going to be, you're going to get consistent read performance, or as far as consistent data when you do reads, but you're going to have slower reads because, you're having blocking calls, which you'll see there in the right read performance, right? But with a event-based data, you have eventually consistent reads. You're going to publish the data in an event, and the consumers that are creating those views, which we'll talk about in a minute, materialized views, based on this data, have to first get that event and then process it to update their reflection of the current state of time. So there's not a single point where they can go query that data. Where's this driver? They're going to have to actually, process all those events to get to that point in time. So it's an eventually consistent read model. Again, we support, fully supported CRUD semantics on a state-based model. You can do reads and updates and deletes because you're having a single state, but you're doing destructive writes. You're throwing away data and replacing it with newer point in time data. Whereas with event-based data, you're only doing creating of new records and you're reading old records. You never do a delete. You never say, as we saw in the previous slides, in the state-based one, you're overwriting the driver's location with the new one. With the event-based, you're just appending the event changes as they occur as a write-only operation. And then the read is obviously reading through those and finding the ones that you want to reconstruct the data that you need. The write performance is slower on a state-based model, again, because you have blocking calls, you have database table locks, you're doing, you have a shared resource, a lot of people coming in at it, so you're going to have some blocking calls there. So your write performance is going to be slower on state-based models, but with event-based, everything is, again, since it's a create and read only, it's non-blocking. It can be done asynchronously. Just publish an event when it gets there, and the reads can come in and they'll get notified of the new events, and they can process that asynchronously as well. But the trade-off is then read performance, right? So once you've paid the price up front of doing a blocking synchronous call and state-based, you can do a very fast point-in-time queries. Again, being the most recent data. What is this driver's current location? It's going to be index data source on a driver ID, so you can do it quickly, real-time lookup and get that information very, very fast. Now, if you wanted to do that same information on the event-based, it's going to be slower because the data itself is spread out over multiple events, whether it's a driver location or if it's a customer, the status of a customer order and all the different items they added to the database, they added to their quote unquote virtual shopping cart as they added items. You have to go reread all those events and reconstruct a view of what that actual order contains, has these food items, that food items, et cetera, will be spread out over multiple events, and you have to read and process all of those first. So it's going to be a slower read. But some of the benefits that you get from event models or event-based models is here in the last two items, right? So evidentiary data, right? So with state-based, you only have the most recent data, and we're throwing away all the previous events. So if we go back and look at the example we had, if we wanted to retrace where these drivers has been or the route they took to go from point A to point B, we don't have that with a state-based model. We just have their current point in time. All that evidence of where they were has been thrown away. All that data is gone. We have no evidence of that. But with the event-based model, unlike mutable tables where only the resulting state is known, event data models are immutable and record the entire history of the changes to the system state. And this provides a detailed audit trail of all the system activity, where the drivers have gone, what changes have happened to the order, did they add items into their cart, take them away later, that sort of thing. So we can use that information to feed different machine learning models and things like that, because we actually have a record of what the customer behavior at the website or driver behavior on the road itself. So it's additional information as well. If you want to prove that somebody was at a point in time where they were, you have this information with event-based model. The other one is obviously replayability, right? It's not supported with state-based. So if you ever have a disaster recovery, you lose all your data. With a state-based model, you're relying on database backups, snapshots, things like that, to reconstruct and put your data back in your database back to where it was before. But with event-based, you have all that data. So again, you can completely reconstruct the database from scratch because you have all the events. So you just replay them again like you would any other view, and you can automatically bring your database back up entirely to whatever point in time you want it to be, including but not limited to the most current one. So this is not only good for existing data sources, but let's say you add a new microservice, you want to have your own view of the data, and so it comes up after the fact. You can construct your own view based on that and reconstruct it from this historical data because that the source data is all there, right? So it's another advantage that you have with event-based model. That's why you make these architectural decisions to use event sourcing. So now that we've talked about event sourcing, we'll talk a little bit about, or about event-based data models. Rather, let's talk about event sourcing. And I think the quote that captured it best here is attributed to Martin Fowler. So I decided to quoted him here, in all respect to him. It's about capture all changes to an application state as a sequence of events. That's really what it is. He's really saying use the event-based model for storing your data. Rather than using a state-based model for that. So every change to an application object or event itself is stored as a sequence of events that occurred over that application, and this allows you to do all the different things that we talked about as far as evidentiary data tracks, and you have replayability. I can go back at any point in time, and I have an audit trail of what happened and what changes occurred. Now, from an implementation perspective, every change made is represented as an event and appended to an event-only log. In this case, we're talking about Pulsar, so it'd be a Pulsar topic, but in general, the only semantics it needs to support is an append-only log, right? So events come in, they're published at the most recent, they're shown on the left, and they're retained, historically. So again, this graphic is showing the driver location, for example. You have some purple events, drivers in orange and blue, and so on and so forth. And they're just dependent in time sequencing. In this case, you're retaining all the events and you retain them in the sequence that they occurred. So the most obvious thing that we've gained by using event sourcing is now that we not only have a log of all the changes, we can just see where each driver is. And not only can we see where we can also see where they've been. It allows us to time travel by restoring the state of the system to any given point in time and rewind these events and reprocess them up, to any desired point in time. So again, if we wanted to do machine learning models sort of thing to figure out how, so we made a change as far as our routing algorithm, right? So, when this food application, drivers are going to sign in, we're going to say you have to go here, but not only we're also going to give them route by route directions, turn here, go up 3 streets, turn left, go this street, turn right. And we want to make sure that, the estimate of time matched what we did. And maybe we want to change that thing and see if it would have, so based on that change, if it actually had the desired income that we want or the outcome that we wanted. And so you can go back and do these sort of replayability, right? It also provides a service autonomy, right? So an event consuming microservice goes down for any reason, it can quickly restore its state by processing all these events in the order they occurred again while it was offline. So again, if you have a microservice that needs its internal database and it dies completely and it needs to restart, you don't have to worry about a database backup. Again, it can connect to do the same processing logic, which we'll see in my example, to just reread all that data quickly. The Pulsar API allows us to do that very quickly, and you can get back to where you were and restore your database automatically as well. Now, the other half, the more important half of the event sourcing equation is called materialized views, for lack of a better term, right? So we have this single source of data, but you want to consume it in different ways. Everybody has a different outcome or desire or way they want to process this data, which is the real another benefit of event sourcing, right? So you have this raw core data, which we'll see in my application is a driver location event. And these driver location, again, is very, very simplistic. It has a latitude, a longitude, a driver ID, and a timestamp of when they occurred, right? And so now if we want to have, different materialized views of this application of this data, we can change it and mutate it, start with the source, process it and use it to feed, different microservices and store an internal state, whether it's in a cache or write it to a third-party system, like a database, for example, process that data and feed a database for, analytics, for example. So we want to do an analytics database. You can take these events, publish it in there. Again, microservices can consume them and pull out the fields that they're only interested in and disregard other, or do some enrichment on it, do some additional pipeline and changing that data. So again, it's a lot of different ways to do it. And you set up these materialized views in a way such that they automatically update themselves when new events come in as well. So these event streams are then designed to be a write once and read many time data sources. And it's common to have multiple views across any event source, which we'll see in my demonstration is exactly what we do. We take one data source and we have multiple views on it to feed different use cases. So when you're talking about these materialized views, there's a lot of different options that you have. Conceptually, all materialized views are created by a processing engine. So I use this generic term here that performs the data transformation from raw event data into the desired format. along with any sort of necessary, enrichments or mutations, type changes, things like that, maybe lookups by a driver ID to add additional fields. For example, if you want to feed, a user survey thing and you want to get that driver information, all you have is a driver ID. You can use that to do additional lookups into other databases to enrich it and that sort of thing. Now, the results of these transformations can then optionally be stored in a more traditional data source stored itself, such as a database or a cache. And then that can be used to feed the queries. So the queries can come in and say, okay, I've processed this data, I've stored it in the database, and then all my downstream consumers can query that traditional data source, or they can be fed directly from the processing engine itself if you're doing a real-time streaming application. So your different processing engine options are include but are not limited to things like traditional SQL engines, where you pull this data from Pulsar topics, you do some processing on it, and then you write it back into a database and you can query it from that application. You can also do it entirely in application code, which is what I'm going to do for this demonstration. Or you can use a more traditional stream processing engine like Flink or Spark to do continuous queries, continuous processing of this data. And again, downstream after you've done that processing, where you stored it is entirely up to you. Now, multiple applications can query these materialized views either from stored data objects or directly from the processing engine itself. And there are several different options or techniques that can be used to implement these materialized views, as I mentioned before, including stream processing engines, things like that. And the examples I'm going to show, we're going to use the application code approach that demonstrates how to implement materialized views entirely inside different Java-based microservices, just using the standard Pulsar client APIs. The most basic primitives that we provide with Pulsar are still able to implement materialized views internally to the applications, and we'll talk about that. So I just wanted to mention a little bit about command query responsibility separation. This goes quite easily, or is paired often with event sourcing. With event sourcing, the data input and output paths are commonly separated for, so obviously you can have independent scalability on both sides, as shown here in this diagram, right? By having write append-only operations, that allows you to have fast and scalable writes. You can have multiple consumers writing a lot of data, very quickly, which in our case, again, imagine a food ordering process application. You have hundreds, thousands, tens of thousands, maybe hundreds of thousands of drivers are writing data continuously. That's a very, you need to be scalable on your writes. You can't have everybody writing that to a single database. It just wouldn't scale. That would become a single point of failure. Data would fall behind, things like that. So you needed to enable things like that. Use cases like that. That's why, you want to separate your write from your read. Similarly, you want to have, read-only operations on your query sides and make them independently scalable as well, right? So the commands are responsible for performing the writes, while the queries applications, as represented by materialized views or backed by materialized views that we saw on the previous slide, are used for the read. So that's the read path. So by providing a separate IO paths allows for higher scalability on both sides, which is why the command query responsibility pattern is the most common implementation of event sourcing, because it allows you to, again, you have separation of responsibility. The queries are responsible for this, writes only, while the queries are responsible for reading the data only. And that's hence the term CQRS, or command query responsibility pattern. So thoughts about, as great as a pattern as this is, it should only be used in certain situations. When deciding whether event sourcing is a good fit for you and your use case or not, consider the following criteria, right? It's not a one size fits all. It's not a golden hammer. Don't try and use it for everything. But generally consider do you need to capture the intent and purpose of every single interaction with your system, or are you only concerned about the resulting state of the system? Right. So for example, do you only care what the final fare charge to the customer was, or do you need to understand how it was calculated? What discounts were applied, what surge pricing was used to calculate the rate? Are there any non-standard charges such as tolls, et cetera, applied to that application or not? Will make a big difference whether you want to use event sourcing or not, right? So if you use event sourcing and you want to factor in tolls because you have to pay taxes on it, you want to do auditing on it, you want to go back and, have somebody come in and look and make sure your search pricing, how it affected your income, like, your revenue for those particular periods, make sure you're doing fair pricing, things like that. Then event sourcing would come into play. If you only care about what the fair charge final fare was, then you can go with a state-based model. Do you need to provide your data as evidence to an internal or external auditor for review? For example, in the event of a dispute, are you able to reconstruct the events that led to your final result? If that result is incorrect, how do you go about resolving it, for example? So again, the fare has changed. Somebody says, hey, I think I was overcharged. I'm a VIP member. I didn't get my 20% discount. You can go back there and see, whether it was actually applied or not with event sourcing. If not, you're just going to have to take their word for it and go in there and manually, if you decide to, change it manually, just manually go in there and make an override of that database value, doing an update, having some sort of audit trail and sign off that says, hey, on such and such a day, I changed it's fair, right? And so that's the trade-off you're going to get on that for the audit trail versus not. Another thing to consider is a natural feature. Are events a natural way to represent the data in your system, or would doing so, be unnatural and would have to have a negative impact on your overall software design, right? Or, think about it. Can you deconstruct your use case into a sequence of discrete events, and each event has a cause and effect, and there naturally can be, applied to your modeling. And, don't force your domain model to fit an event-based system if it is not a natural fit. And then last but not least is, flexibility, right? How flexible does your data model need to be? The more consumers you have of your data, the more requirements, requests they're going to have to add fields and or features to support non-business related capabilities, such as reporting and auditing, et cetera. So you could start with a core database schema and a state-based model. Say this captures my business use case. These are the core fields that I need. And then as more as you open that field up, that database up to other consumers, whether it's directly or through a replication, and then doing reporting on it, they're eventually going to, that becomes an API that your other consumers are going to have inside your system. And they're going to invariably, like any API you expose, is going to change. People are going to want new features, new things added to it. And by exposing it in a state-based model, you're exposing yourself to having those mutations and those requests make their way back into your core database table. And then it's going to make less and less sense to you from the domain perspective. You're going to start losing track of that, and things are going to start changing. You're going to have fields that are not going to have default values for you. You're not be able to put them in as part of your natural flow. And so that becomes something that you may have on that. So if you start with a state-based model, it's less flexible. But if you have a core event-based model, you can provide, more flexible data models, because again, you write it through a processing engine. They can do enrichments. They can each do their ETL pipeline to do their own augmentation of the data themselves based off of that core data model. And then they can build their own databases as to sort of suit their needs and meet all their business requirements. So those are the different trades off that you need. If you don't have if you don't require flexibility in your data model, you can get away with state-based. But if you're going to require flexibility, then we recommend using event sourcing. That's one of the criteria to use when evaluating whether to use it or not. So now, enough talking about the theory. For those of you looking to see some code, let's go ahead and get into this. Now we've had sufficiently covered this. Let's focus on a single event type and see how we implement that. And there are going to be two different materialized views that I've created from the single event source to support these different use cases. So we'll start by, this is what we're going to show. You have a user interface layer, and we have different business personas here on the left. So you have obviously the customer persona is going to come in. They need to get some information. The drivers are publishing their information here, and then you have an analyst that also needs access to the same data. Now, the drivers, as we saw in the first slide, are going to be publishing their different data, right? So this driver location service listens for incoming driver notification events and writes the data to a Pulsar topic. Now, when a customer signs up for our application, they get their own version of our mobile app. And when they sign in, we automatically register them. And as part of that sign up, we're able to capture their geographical location using the location service embedded in their phone. We have their driver ID, and then obviously we use the timestamp, the phone feature on the time feature on their phone, and we gather those 4 pieces of information and we publish it to this driver location service automatically on their behalf. And so every 10 seconds we're sending there's this method called record signal that intercepts these information coming from the driver's mobile app, over REST endpoint, and we get this information, and you're able to, and we store that information. That's the only right path into the driver location events in our event store. All the other 5 features here are materialized views into the same single event source, right? And so the driver location service here, I have a list field, which we'll show first, which is just a sanity check to list all the different events in that service. So you can go back and see where all the drivers right now, get a complete list of where they are, sort of thing. We provide that as a list method. There's also a driver analytics service that provides various real-time and near real-time views of the data that are geared towards analytic use cases, things like heat maps of driver location density by geographical region. Similarly, where do we have our fleet placed properly relative to where we anticipate our customers signing up, and based on perceived patterns of usage in the past, are we making sure that people are in the right locations? That's the heat map, or you can drill down in and say, give me a heat map within a grid ID and show me that information. And then last but not least is this driver tracker service, which is what the customer interacts with. And that goes to the point of, the use case where, you're signed in with your driver and you want to see them en route to your individual location. This gives you real-time notifications on your mobile device of how they're tracking and what their ETA is. So there's all these different information, all these different views are going to be fed by the single event source here. So again, as I mentioned before, there's this update driver position command. This is the write operation, and the driver location service that I'm going to show exposes a REST endpoint that collects the driver location information. These positional updates are automatically sent from the mobile application that drivers use to connect to our system, and it gathers that location information, like I said, from the phone and publishes it there. Upon receipt of this information on the REST service, which I'll show you, the events are then enriched with a grid ID that is used to further identify the larger a region in which the driver is associated with. And we use an open source library from Uber called H3 that actually does this for us, right? And then once that data is enriched, we write it to another Pulsar topic, or we write that data to Pulsar topic, and that becomes our event store. Now, this single event topic then serves as the data source for all the materialized views used throughout the rest of this demo. And this is a good example of the one data source feeds multiple views scenario that I talked about earlier. Now, the other view I'm going to show you is this use case here, talk about the driver location, right? So this is the assigned driver location scenario. So once a driver has been assigned to a customer, we're going to provide that customer an update of the driver's current geographical location, so they have a rough idea when the driver will arrive. Everybody likes to have the food in progress. Hey, where's my food? Order my hamburger. Where the heck is this guy? Right? Come on, I'm waiting for the food. And so we give them a real-time feedback of where this is. And this is the driver tracker service, which will show in the code that provides this functionality by using a materialized view of the driver location event stored inside Pulsar topic that filters that out by a specific driver ID, right? So we get all this, again, this topic has all the driver information, all the drivers across the world. We do a filtering down to your individual driver, and then we can feed that back to the consumer. And since there's no need for historical data in this regard, in this case, the view uses an exclusive Pulsar Consumer, which actually creates a subscription, very quickly, and actually receives location updates as they come in. So it bypasses going to the store, and it gets the most recent data only, and can skip all the older historical data, but it still updates this information, right? It then uses this filter event data to populate the driver's position on the map inside the customer's user interface, and it updates in real time. And we'll show you that graphically, although it's a very primitive demo, but it still works. Then the other one I'm going to show you is the analytics use case. So a materialized view can also be used for analytical use cases as well. In this particular use case, we're continuously processing a sliding window of the previous 5 minutes worth of location data to determine the total number of drivers within each geographical area or grid, as shown here, and then produce a heat map. And this information is used to produce this information. I'm going to show it to you graphically, but in practice, it would probably more likely be used to feed a real-time database, to feed various dashboards or automated decision-making tools that drive real-time surge pricing. So we incent drivers to move to areas such as this one here that's not properly, it doesn't have sufficient density of drivers relative to what we anticipate the amount of customer demand to be. And I'll demonstrate how this data can be visualized inside a web browser for real-time analysis by data science professionals and things like that. This is just one example of analysis of data that can be done. Similar views can be used to calculate the average speed of drivers within a region relative to the average speed observed previously in the past. So is this indicating a slowdown in this region, and we want to route people around for a routing application? You can look at it and say, hey, avoid these 2 grid squares because our measurement now is relative speed. There's a slowdown, and we can reroute them based on that information. This is just one example of that. Where you can use it to detect traffic jams as well. So there's lots of different ways to process this data in an analytical use case. And so without further ado, we're going to switch to showing the demo. I want to highlight here, if you take a second, that this code is available on my personal GitHub, or we're going to move it over as well. It's publicly available. Feel free to play with it yourself and things like that. But let me go ahead and switch over the code now. I'm not sure if I'm going to share my full screen. I'm sharing desktop too. Hopefully you can see this.
You can, thanks.
Thank you for confirmation of that. So we'll start with the code and I'll start them up. So the first one is, I use Quarkus as a backend just to show you how easy it is to minimize the input. So as I mentioned before, the location service is first. This is the REST endpoint that we have. It's going to collect this information. So in this particular case, we expose it at the API, which is this driver location resource. So again, it has the full path of location.driver. When you post an event to this REST endpoint, this record signal event is called. It has a position signal, driver position signal, which contains those four fields that I mentioned: driver ID, location, latitude, longitude, and timestamp. We delegate then to a service to record this information. And what it does is do the enrichment and then write it to a Pulsar topic, right? So this is, again, the service. So the driver location service is here. It calls the record method. And as you see, we create a driver location field because it's a different type. So we change the type. It's a one-to-one mapping. We just copy the data over. Then we call the enrichment, right? So we have this lookup bean, which is just an H3 core field that does the lookup for us. It's an Uber open source library, as I mentioned. And basically you pass in a lat long field and it gives you back a grid location ID based on that. So we get this grid ID as we'll see in the UI. It creates this new field. Once we have this new enriched data, we take the producer, which is a Pulsar topic, the Pulsar producer here. We've connected. We're saying we're publishing JSON data. This is the topic we're going to write to, which is configurable here as a configuration parameter. So we can change this. It's public default driver location. Excuse me. That's going to be our core data. We also extract the event time, so we can add metadata to each Pulsar event, which is what makes it extremely useful for event sourcing. Not only do you have the metadata and all the data that you need inside this JSON object, but then you can tag it with additional metadata as well. So in this case, we put the event time. We can get a key and key it by driver ID. So if you want to do queries on it later by driver ID, which is what we want to do, we can use this key field to do key-based or key shared subscriptions and make sure we're processing all the same driver ID by the same consumers and things like that. You can also add properties. You can tag metadata as well on there. And when you're done, you just process it. That's it. That's as simple as writing the data in becomes. So let's go ahead and start this web service, and hopefully I didn't break it. You can start it since it's Quarkus. It starts in the dev environment. I like it because the code picks up code changes automatically. You don't have to restart your application. So if you have a little whoopsie moment, you can go ahead and do it. You go ahead and get started on that. And then we'll go ahead and show that it goes and feeds this REST endpoint. I'm querying it, and you can see I put in some data in the past. I was getting ready for this demo, so you can see it's pretty old, but there's different drivers IDs, and this is historical data. So this is the use case I talked about where, hey, I'm starting it up from scratch. There is no data. What it did is it went back and it reread all the data, right? And this was done, here when we first started it. You just do a quick lookup. It goes and gets the repository, and this is where. So we're calling the list method on that. This was the materialized view I showed in the slide where we're doing a list, right? So first we have to do is get a reader, and this is going to go get historical data. In this case, we say I want to get as early as you can, go back as far as you can, and get this information, and put this information in our location data, right? So just go in and create an array of this information, and we're reading it directly from a Pulsar topic. Again, everything's the same except we're using a reader interface. And in that case, we do a next, right? So you seek to the first, you check why you have messages available, and you get all that information, boom, you populated that. And so this is all historical data, not live data. So now that's kind of interesting, but that's great. Now let's get an actual driver simulator. So what I've written is a simple command that will simulate 5 different drivers driving around the greater Chicago area. If you hadn't noticed, that's where this lat long comes from, information. And this guy's going to start producing events, right? So he's running, and we should see now in the log for the log service, this REST API is going to start receiving events, new information coming in. There we go. Right. So I've received these signals. So we got 5 new drivers coming in. We've got 5 new signals. If we go back and query the data again, now we see that the new event data came in, right? This is in real time. We're getting this information. It's all encoded. So this is just showing us that, again, we're showing that this event source that we have has old data, has new data. As it's coming in, it's being appended to the driver topic, right? Sorry, get out of here. Find my way around. Too many screens open. So the next use case we're going to show is then the tracker, right? And so with the tracker implication, let's go ahead and close these guys, get them out. The tracker location is actually very, very simple. I've exposed it as a simple web socket. Come on, open for me here. So it's a single class. Now, when you query and connect to this endpoint, again, it's as over a WebSocket address, and you specify the track. It's a tracking endpoint, drivers, and you parameterize it, give it a specific driver ID that you're interested in tracking. That goes back to, okay, I've been assigned driver this. I come in and I subscribe. When I connect to it, you're going to call this on open method, right? You can see it's parameterized as well. So we're going to read from that same topic we were publishing to in the previous in the location service REST API. That's going to be our data source. Now, when you come in and you first connect, this on open method is called, and it has the driver ID that you're requesting. And what we're doing is we're creating a map of sessions, and so there might be multiple users tracking the same driver for whatever reason at the same time. And so we first see if that exists in the map, and if it is, we add it to an array list, or we create an array list for the first time, and then we add it to that particular driver, right? So once we have once you register interest in this driver's location, we add you there and we record it in a map, sort of thing. And then we kick off the consumer, which is the key to feeding this information. And that's how we do the materialized view for the real-time data, which we'll talk about. We'll show here in a second. Just the on-close method is when you close that WebSocket connection, it deregisters itself. So we go ahead and clean up these sessions, so we're not broadcasting to a lot of different dead connections. Nothing really interesting here. This notified method is called by the consumer itself, which we'll talk about, right? So once we registered a session and we start a Pulsar Consumer. Now this Pulsar Consumer, again, uses a standard Pulsar client. We know we're reading this particular type of data. We're subscribing to the topic. We're giving it a unique name, and we're starting at the very latest. We don't want any historical data. We start the soonest data, and we're doing an exclusive subscription type, which means we get all the data. Now, one way of programmatically declaring what you want to happen when a new event occurs on every event is this message listener field here. As you can see, we used a lambda to specify, pass in all the parameters. So the con parameter is the consumer, so we can do acknowledgement, and the message is the actual message itself. So every time we get a new message coming in, we first see, hey, again, that was the key value, right? Remember, we put the driver ID in by the key. So we look at the key and we say, hey, do we have is anybody interested in being notified about this driver? If it is, then we can call that notified method internally and pass the information. If not, we just acknowledge, then we just skip it. But either way, we acknowledge the message to say, okay, I've gotten this message, and move the cursor forward, so we're not going to reprocess it again. But if it is a session that we're interested in, then we're going to call this notified method with the driver ID and the actual location value itself. And now this notified method here goes back and looks at the sessions for these driver IDs, goes through the entire list, and sends and asynchronously sends a location value back. Again, as a string, we take it and use the mapper object to turn this JSON object back into a string, and we send it back out. And then, as we can see, as I'll show you here in the the web page that actually tracks it. We get this information here. When we connect to it, we create a WebSocket to connect. In this case, I've hard coded the value 1 just to make it easier. So we're tracking always driver number 1 because I know he's there. But this is the method that gets called when the notification calls. This notification method here, the send object, this async remote, triggers this event getting called, this on message. And so we know what the data is, so we parse it first, and then we're updating this map location. As we'll see here, it's a street map, and we update this. So let's go ahead and see this in action if I can. 1 second. So we'll go to screen number 3. This is the driver tracker WebSocket service. He started the exact same way. Hoping that we don't get any sort of abuse. Okay, that one looks good. That one is exposed at this particular URL. I changed the port number, and as you can see here, so it starts with its initial, and there it moved. So every time I get a new update, it's going to update this cursor position on the map, right? So every 10 seconds, this guy should jump here again in a second. Jinx it, now there it did move. Obviously, you can see it's a random location because he's floating through the air rather than staying on the street. So it's more of like a virtual helicopter. Maybe I'm using drones to deliver the food. I don't know. But you can see the point is that the data is getting real data from that topic. The event is the source, and it's updating the UI based on that information as well. So this will continue to move all day until you end the service. He's jumping around in real time and updating his location. And then the third and last one is just this heat map. Again, I got too many screens up. Is the heat map one in analytics, right? And so I know we're getting close to time, so I'll try to get to this. This one again is we're going to have an API. So this is the web interface one where you can call get the heat map, or you can get it by grid ID if you want to drill down into a specific grid ID. In this case, we're going to do the get heat map, and he goes to the repository. I call it a repository is where we're going to store a cache of. We build a cache of all these driver locations based on the historical data as well. So you start up this driver location object. It has an internal cache, which we configure to sort of age out data, right? Again, we're only interested in the most recent data. And so we have this, I use the caffeine cache, but it's basically a purgeable cache that can expires the data after, 5 minutes, 10 minutes, because we don't care about driver location data from 2 hours ago. We care about the most recent one for this analytics, right? We want to limit it to 5 minutes on that. So it's going to be stored in an internal cache, and that's where this comes from. We just inject it, boom, it's there. Again, you can see we're going to the exact same event. So again, we're going to that event source. This is the Pulsar topic we're going to read it from. We use a combination of a reader and an active consumer. So the reader is going to go get our historical data, and the consumer is going to listen for the most recent data on this. And the key being here that when you first start up, we populate that cache with historical data using the reader interface first. Then we launch an active consumer to get, once we've caught up to the data, we're going to continually update this information, right? So first we create the reader, we go through the same logic of while it has available, get the next value, and then we update a map, right? So we put a driver location and his current lat long. And since we're processing that historically from oldest to newest, if we have multiple entries for the same driver ID, which we should, the most recent one's going to clobber the older ones. And at the end of this processing loop, you're going to have the most recent one from historical records. You'll have the most recent one you had. Once you're done and you've populated with all the historical data, so you've caught up, you've come up, you've got it yourself, reconstructed your internal cache, your internal materialized view internally with the code, then you want to keep it fresh by starting the consumer. And this consumer does exactly what we did in the previous one. Before we use the Pulsar client, we create a consumer, we create a different subscription name. We want to start with the latest one we haven't read. We have an exclusive subscription type, which means we want to get every single record no matter what. And then again, we use the message listener interface again, but in this time we're not filtering every time we get an event. We take that driver ID, we update the cache, that value, that driver's ID with the new lat long based on the value they just published it, right? And update that in the cache. And that's it. And so we're keeping this event up to date. And then when they want to get the heat map, we call this report method, which basically goes through and creates a summary location. The data has to be constrained within a box, a lat long square, and a count so you can get a density. And so it's not just putting plots on the map, but it's actually doing a count within each lat log space, and we're doing a summation of that. So when we first see this guy and it's a new location, we add one. Every point afterwards, we do a sum plus one, and so you get this density going on, and then how that visualizes itself. Where's this thing? Where did my screens here? Is this guy? Oops, I don't want to do that. Is a dev service. We're going to start this guy up again using Quarkus. It's the same command. Here, he uses the screen, this heat map one here. And as you can see, based on where these drivers are located, the higher the count, the denser the color is, right? So red meaning I have a lot of people, a lot of drivers in this location, yellow's less, green is less. The ones don't register because we have the granularity such that we don't want to see every individual driver. We just want to see pockets of where people are located. And as we expect it to be, you have, people by the O'Hare Airport, you have some people down by Midway, and you got a lot of traffic downtown within the loop there in Chicago as well. So you can see this graphically. And again, it's updated in real time. So when a new event comes in, WebSocket's going to feed this web page. It's going to update it, and things will the density will drop, and the new hot spots will pop up and things like that. And so that is really it in a nutshell. We have 5 minutes left for that. I'm going to switch back to slides and talk about a summarization here real quick. So key takeaways. Hopefully you found this educational. You found the source code to be useful. You can play with it as well. And just talk, understand event sourcing is a great way to approach storing data that needs to be consumed in multiple different ways and updated in real time, via materialized views. I think Apache Pulsar, with its infinite scalable storage layer and its use of tiered storage and its natural construct of an append-only log using segment-based storage, that Apache Pulsar is a great option for event-based storage because you store it naturally in an event, right? You publish messages, you read messages. So we have a full API to put and get, and then it's up to you to process those. And we have full control, granularity over how you can consume those messages over and over again. And you can, set the position, set your cursor position, and have full fidelity over how you process that data. Finally, we covered just a few of the different ways in which Pulsar API can be used to create materialized views or event data, right? We show the reader interface that allows us to time travel backwards and reprocess data in the past and reconstruct a materialized view up to the current point in time. You could also stop previously. And the consumer interface that allows us to receive new events as they come in real time. And so we can process, just that data and bypass going through a database entirely. Again, that was just one option. Pulsar also supports Flink connectors and Spark connectors natively. So if you want to use Flink, for your event sourcing, do some analytics, rope analytics, things like that. We're just scratching the surface. All that data can be stored in Pulsar, and there's lots of different ways to get at it. We just covered a couple today. Before leaving, a couple calls to action things. If you want to follow up on this, I did a building microservices webinar previously, which would be a good fit because event sourcing is a great fit for microservices. Again, the philosophy of microservices being every microservices has their own quote unquote database. So again, you can reconstruct your own database per microservice by using event sourcing as the way to store data. And then you construct your own customer view or driver location view or whatever you want to do based on that. So it's a good fit if you want to revisit those webinars and time together. There's also blog posts on this, on that same topic, event-driven microservices using Pulsar and Pulsar functions. Last but not least, there's some on-demand training for Pulsar. So go to academy.streamnative.io. It's free, it's self-paced, it has interactive web browser and exercises, source code. You have access to an actual Pulsar cluster, so you don't even have to stand one up to start playing with the API. If you want to bring up one of those things and walk through that training course, we highly recommend it to get you an introduction to some of the topics I glossed over here, assume that you knew. You can catch up on that information. Last but not least, let's keep in touch. This is my Twitter handle. This is my LinkedIn handle. That's the GitHub repo I pointed to earlier. It has a source code. There's other stuff in there. Source code for my book, Pulsar in Action, again, is there. NiFi connectors, other cool stuff's in there, all kinds of stuff. I got a few few projects you might be interested in as well. And then I know we have a lot of questions came in a short time, so I will hand over Q&A, and I'll let Karen read me some of
Yeah,
these.
I'll chime in. So, for anyone that does need to drop, thank you so much for joining. And, David, thanks for all of your expertise around this. But we will continue on for those of you that are able to stay. So, some great questions came in. I'll just start at the top. Is there a best practice for replaying the events on top of a materialized view snapshot as opposed to starting from the beginning of time?
Yeah, great question. It really, I had a great discussion with Jill's, which is our director of European operations. I forget if I get this term wrong. He was questioning that as well. It's a really great topic that comes up about how you store this data, right? Because the replayability becomes painful if you have 3-4 months or years worth of data and you want to get back to build it up, right? That's a lot of processing to get up, from the beginning of time. And so first I break up the world or data sources into two categories. In this particular case, we saw that the data it loses historical value very quickly, right? I'm very unlikely that I'm going to need to care about where a driver was 3 years ago, other than, if I really need to go back and as auditing, or, somebody comes in and says, prove that this driver was here at this point in time, right? That's going to be a one-off case. That data is very perishable time-wise. And so you don't really need to even keep that, and you can sort of siphon that data off, using what they used to call a wiretap pattern in the old enterprise integration patterns thing, where you basically listen to the source topic, write it to a separate Pulsar topic, but then using data retention policies of of under an hour to truncate that data very quickly, right? So your beginning of time becomes much less, because you don't care about you only need an hour's worth of data. But if the other side of the other side of data is, I actually do need all this information. I'm trying to reconstruct the entire customer order database from the point in time. So I need all the event, order entries coming in, all the different topics, and I'm retaining that data, and we store it infinitely, sort of thing. And so a way to approach that, and we talked about, is sort of checkpointing, right? And so you're going to build using the concept of checkpoints, which is common to people like Flink, people who use Flink, for example. You process a certain set of data, and then you update it, and you do a snapshot. And what you do is you would actually do a backup of your database state. Let's just say you're putting in a relational database inside like a microservice or something. So you have an embedded relational database, and you're trying to keep it there. You do a snapshot. You replay 1,000 records, mutate your database, do a snapshot that message ID as well as a cursor position, right? So when I need to go back in time, the most recent one, I can grab that database that's been partially constructed and saved somewhere, which again, I recommend like a Pulsar state store. You can save to disk, do a snapshot of an hour ago, and then you have a corresponding message ID in your Pulsar topic. So when you've got to go back to your reader interface, those two are married, and they go together. So when you want to restore it, you go back and get that information, and then you're replaying only a partial event of that particular data to totally bring back your database back to its full natural state.
Nice.
Yep.
Next one, a scenario. When I reach home lock, I will open and light will turn on. Light and lock and lights come from a different vendor. Can I manage this with Pulsar? Is this an example of event sourcing?
You definitely can. So the first question, you definitely can handle that with Apache Pulsar. Again, as long as they can publish, you can get their events, again, the lock and the light, to publish to some sort of endpoint, like a REST endpoint or WebSocket endpoint, that you can write a simple service like I did here to listen to, so everybody can publish to a known interface, whether it's even, and Pulsar supports MQTT and other protocols as well. So you can support, short wave protocol transmissions as well, to do those sorts of things for you and get it into Pulsar. Once you do, then you can definitely manage that information. And that would be an example of, current state, so you'd have an event, light went on at 5 o'clock, lock closed at 9 o'clock, and you could replay, when your lights went on and off in your house, and when the locks went on and off in your house, and have that information for all time, and use it however you wanted to. Yeah, absolutely.
Okay. Two more. Can Pulsar compile natively in Quarkus? If so, what library do you use for Quarkus applications? And I do believe Tim put some additional references in chat for that as well.
Yeah. Thank you for that, Tim. I'm going to plead Quarkus ignorance. The reason I use Quarkus, because I wanted to play with it a bit. full disclosure, I found it to be really cool. I wanted to see how easy it was. I found it to be, again, I self-taught myself this in a week. Super easy to use. I don't see any reason why you can't. I think, again, if you look at the source code there, the Palm has a way for native builds. So, but I have not taken that next step to try to deploy it natively and run it. So I'm going to defer on that one and punt to whatever Tim said. He may have some different insight than I do, but I don't have any information beyond that. Sorry about that.
Yeah, I think in chat it added, Tim added in that the app using the standard Java client library for Pulsar and put the link in there also. So
Yeah, yeah, we're just using a Pulsar, but you can use whatever you want. Again, it's just Quarkus is a very flexible framework, and I found it to be very appealing. And again, you saw how easy it was to write a REST endpoint to publish all this data and very quickly. So it's literally 2 classes, and I'm able to do all these cool things. So very cool.
And one more coming out of chat. Did you ever try to address the common pitfalls which Kafka has when it comes to implementing event sourcing with it? Does Pulsar provide anything for optimistic locking if I want to run a command against an aggregate, validate it, and after that add an event to the Apache Pulsar topic? As you can imagine, I need to be sure that no one else updated my aggregate before I have the chance to do it.
I have not given that use case consideration, so I'll have to pause on that. We do support full transaction. We have a transaction API now. So if you were to incorporate that transaction calculation and publish within our Pulsar transactions, then that should work. Again, in theory, so you would start the transaction, perform your aggregate sort of thing, and then make sure there's an update. I guess I'm not sure if we have an exclusive lock scenario, though, that would prevent somebody else from mutating that topic while you're in the midst of a calculation. So yeah, that's one can't implement a distributed lock on Pulsar. So cool.
Yeah, looks like Tom added some onto the chat also.
Thank
you for that. Yep.
Yeah, in code you probably could, but again, it's a backdoor. I don't know how you would stop everybody from getting in there necessarily, producers. So we have to see. Yeah.
It looks like that ties up the questions that were available in the chat and Q&A, and I know we have run a bit over on this. So I'd like to go ahead and conclude out today's webinar and thank everyone for joining us today, and also big thanks to David for sharing his expertise around this. If any of you have any questions, please don't hesitate to reach out to David or anyone else on the Stream Native team as well. We're happy to help. Everyone will be getting an email that will have links to all of the resources. I put those in chat also. But we'll make sure that you've got links to all the resources that David mentioned, as well as to the recording of this webinar. But with that said, thank you to everyone, and please do go explore the free training that's available. We just introduced the 101 course, and we'd love to get your feedback on that also. So thank you, everyone, and appreciate everyone here. And David, thank you. Have a great day, everyone.
Thank you, everyone, for attending.